Today we'll start on important topics related to measure theory. Okay, that means we talk about LP space now, and we're also going to forward discussion of now we discuss measure and sign measure. Okay, in previous class we also discuss measure and sign measure. Okay, then we now talk about that finite signed measure. Okay, finite sign measure we also talk about today. Okay, so what is this? We write from definition first. Let x a mu be a measurable space, be a measurable space, and mu this a this algebra to minus infinity plus infinity be a sign measure. Okay, then what happened? Then x this if a mu be a sign measure space. Okay, and we're now going to define finite sign measure. Okay, so when we call finite sign measure a set function mu. Okay, here script f to minus infinity plus infinity. Okay, it's called finite sign measure. Finite sign measure if mu a belongs to open minus infinity open plus infinity. Okay, for all a belongs to this script a. Okay, so we also write this definition of finite sign measure. That means just resulting value of measure belongs to open minus infinity and open plus infinity. Okay, so we're now going to, that means, write some example of that. Okay, or is that person and going to write some example of finite sign measure. We write here example. Okay, so let x a mu be a measure space, and a belongs to this algebra, and if e to r be a measurable function, okay, then what happened? Then integral of f over a is integration f d mu over e equal to integration of e f plus d mu difference integration of e a minus d mu. Okay, then what happened? Then we also talk about that if integral, then what happened? Okay, we know about that. Here we write if is said to be, f is said to be integral if integration of e here if d mu less than plus infinity. Okay, here mod f d mu less than plus infinity. That is what happened. That is integration of e. Okay, f plus d mu belongs to close to 0 plus infinity, and integration e f minus d mu less than less than plus infinity or belongs to close to 0 plus infinity. Okay, then what happened? Then we talk about that. We write it in this way, gamma a, not a here, e. Okay, gamma e integration of e f d mu. Okay, integration of f d mu, f d mu, obviously be a finite measure, be a finite signed measure. Okay, so also write definition of finite signed measure, and we also gives one example related to finite signed measure. Now we're going to further discussion of monotonicity of this measure. Okay, signed measure. So now we erase that portion and going to further discussion of that. If we write here therefore, then this one is better. Okay, we erase that portion and going to further discussion of that. Monotonicity of sign measure. Okay, now we also talk about that monotonicity of sign measure. Okay, so we write here some domain x equal to 0 to 5 closed. Okay, a equal to here m equal to all Lebesgue measurable sets, all Lebesgue measurable set. Okay, and m small m equal to Lebesgue measure on this m. Okay, now we're also going to define here let f close 0 to 5 to r be an integral Lebesgue measure, be an integral Lebesgue measurable function. Okay, then what happened? Then the third function, okay, then the third function gamma a, here gamma f we write a, gamma f a equal to integration f d mu with respect to A belongs to this M. Okay, each finite sign measure also discussed in previous example. Okay, each finite sign measure. Now we also take this f equal to this take this f equal to taking this fx equal to sin x. Okay, taking this fx equal to sin x and gamma a equal to integration of a sin x dx. Okay, then what happened? Oh, sorry, not dx. Here we write dm, measure, with respect to measure. Okay, then what happened? Okay, here we write not d mu, dm. If we write dm, because here we construct m is the measure, Lebesgue measure. Okay, then what happened? Then we also going to be write this one. We erase that portion. Okay, here a equal to 0 to pi. Okay, and b equal to pi to 2 pi. Sorry, b equal to 0 to 2 pi. Okay, then what happened? Then this one gamma f a equal to integration of 0 to pi fx dm. Okay, difference minus cos x 0 to pi equal to here plus 2, because cos pi minus 1 0 minus 1 cos 0 1, then minus 1 here plus 2. Okay, here this one we write it better than cos pi difference cos 0, then this one. Okay, next again we write gamma fb. Okay, gamma fb we erase lower portions now. Then what happened? Then we write it about here 0 to 2 pi fx dx dm equal to here integration of 0 to 2 pi sin x dx, sorry, sin x d with respect to dm. Okay, and here we talk about dm equal to x. Okay, then what happened? Then here obviously 0. Okay, then we note about that a subset of b, because 0 to pi closed and 0 to 2 pi closed, obviously a subset of b, but gamma a obviously greater than equal to, sorry, not here, oh yes, gamma a gamma f a gamma f b. Okay, this one happened. So what happened next? So we talk about that we here write 2 greater than 0. Okay, so we talk about that, hence sign measure, hence sign measure gamma f be not monotone. Okay, we also see about that monotonicity of sign measure not occur. That means sign measure is not satisfied monotonicity property. Okay, I understand about that, not a problem at all. So now we're going to subadditivity for the property. Okay, here we goes now subadditivity property of sign measure. Okay, now also discuss same problem. Okay, we know about that this x equal to 0 to pi, and obviously if 0 to 2 pi to r, okay, be an integrable measurable function, be an integrable measurable function, okay, then what happened, then set functions gamma a equal to integration of a f t n, okay, for all a belongs to this measurable set and m be the measure, okay. Then what happened, this one is finite signed measure, okay. Now we write it now here. Take a equal to what, pi to 2 pi, okay. B equal to what, 0 to 2 pi, okay. Then what happened, and obviously we know about that. So A union B equal to obviously 0 to 2 pi, okay. That means B. So if we write here comma A, okay, sorry, here we write that means comma A, okay, in this way, not so gamma A equal to what, integration of pi to 2 pi fx dn equal to integration of pi to 2 pi, okay, sin x dx equal to what, equal to minus cos x here pi to 2 pi, okay, equal to what, equal to minus cos 2 pi difference cos pi equal to minus 1 difference here minus 1 equal to minus 2, okay. And comma b equal to what, and comma b equal to integration of b with respect to b fx dn equal to 0 to 2 pi here sin x dx equal to 0, okay. Now we erase that portion and going to further discussion of that, okay. So what happened, so here we write gamma a equal to minus 2, gamma b equal to 0, and gamma of a union b equal to 0. So what happened, so we write here gamma a plus gamma b equal to what, minus 2, and okay, and then what happened, then obviously gamma A union B does not less than equal to gamma A plus gamma B. Okay, so what happened? So subadditivity property does not hold. So subadditivity, okay, property does not hold for a sign measure. Okay, so subadditivity property does not hold for a sign measure. Okay, then today we discuss one important, that means topics related to sign measure. Okay, first we talk about finite sign measure. Say then too easily we discuss this one. Okay, first we talk about finite sign measure, example of finite sign measure, then we talk about monotonicity of sign measure, then we talk about subadditivity of sign measure, and obviously gives corresponding example, and obviously that means discuss so easily and too elaborately. I think all I understand about that. So if you get this type of video, please subscribe my channel, and if you give like, please, that means raise like option, and if you have any questions, please give, that means write it in comment box. Okay, so please subscribe my channel if you get this type of video. So today I stop here. Okay.